Our topic for this morning is about chemical treatment of wastewater. But before we'll proceed with our lesson, we have here an activity to activate your mind and for you to recall what you have learned in your chemistry subject as a prerequisite of this course. So this one start with letter N and end with letter N. This one start with letter D and it ends with letter N. And this one start with letter C and ends with letter N again. And this one starts with letter F and ends with letter N again also. And this one for sure, you know this word, right? Okay, let's get going. Chemical treatment. Chemical treatment process is very important in treating the wastewater. In this process, we are adding chemical reagents into the wastewater. In such a way, we are going to remove the acids, bases, colloidal matter, color, trace metals, and dissolved solids in wastewater. The first is neutralization. Here in this process, we should identify first what is the pH of our wastewater. Of course, if the pH of your wastewater is acidic or the pH is below 7, so we're going to neutralize the wastewater. So to neutralize an acidic wastewater, we're going to add alkaline or base reagents. So if it is acidic, we're going to add commonly sodium hydroxide to neutralize the wastewater. Or if you have a pH higher than 7, we're going to neutralize it by adding sulfuric acid. In a way, we can achieve a pH of 7. And when we reach the pH of 7, as the result, the pH of your wastewater will be near 7. So therefore, it is already neutral and therefore it is not corrosive already. We have a wastewater and we are going to neutralize the wastewater. We're going to add the phenolphthalein as an indicator. If the water after adding phenolphthalein turn into pink or dark pink, meaning the solution is acidic. So we're going to neutralize using base. So in neutralization, we're going to add base solution or reagents into the wastewater. And if we observe that the wastewater turn into a clear, meaning the wastewater is already neutralized. The next process is redox precipitation. Recall in your chemistry that when we are talking about precipitation in chemistry, the byproduct of the solution is a solids, right? So we have here, we are going to add oxygen as the common oxidizing agent in the solution or in the wastewater. If we're going to remove the iron and manganese in wastewater, we can add oxygen. In a way, our product will iron and manganese removal by reaction in the presence of oxygen. So we have there the presence of iron and manganese in the water, and we add oxygen into this wastewater. So the product are the precipitates of the following compound. So this is the ferrous oxide and the manganese oxides. So they are in solid form. As you can see, they are arrows moves downward. And also, fluorides in the water, as we have mentioned, the presence of fluoride in the water at very high concentration can cause dental fluorosis, or worst is bone fluorosis. So that is why at high concentration they should be properly removed, and it can be removed by addition of lime. So the fluorides ion added by calcium hydroxide. So our solids that can be removed from the solution is calcium fluoride and hydroxide ions. Next is the removal of hardness using soda ash. So calcium and magnesium causes hardness in the water, and it is undesirable in the water or in the wastewater. So we're going to add soda ash, or in other word as sodium carbonate. So if we're going to add, so there is an exchange of ion reaction. It will form calcium carbonate and magnesium carbonate, and it will produced in solid form. So that is how you have a precipitate sign here in the reaction. And another one, by using sulfuric acid. If your solution contain aluminate, so you have there sodium aluminate, you're going to add sulfuric acid because alum is not good for human consumption. It has a bad effects to our body. So that is why we need to remove the aluminum hydroxide. So aluminum hydroxide is the product of the solution, and it is in solid form. It can be removed. So this solids product can be removed by sedimentation process, right? We're going to remove the clear water with the solids. Also further can be removed by other physical process like filtration and so on. So what we have here is the coagulation. It is an electrochemical process by which you are going to remove the colloidal matter in the wastewater. So we need to remove those colloidal matter or the suspended particles in the water because those colloidal matter or solid particle or suspended particles in the water or in the wastewater could be hiding places of different kind of microorganisms. And we are going to add coagulants or coagulating agent that can reduce the electrostatic charges surrounding the colloidal matter. And then we are allowing the natural van der Waals forces of attraction to predominate and allowing the solid to cluster. And these are the common coagulants, the alum, or what we have also called the tawas, and the copperas. So this is the schematic diagram what happened during coagulation process. So this is your water with many impurities, suspended particles. Those suspended particles are in colloidal suspension here in the water, and we are going to add coagulant into the water, and then by stirring, rapid mixing process, those impurities stick into the surface of those coagulant. So as you can see, it coagulates and it will become denser than water, so it will settle down after rapid mixing. And you can now remove the clear water from the upper part of the water. So we can have a video on that as shown in the following. Particles are negatively charged, or the zeta potential are negative. So the to continue suspended in the water because there's no attraction of forces in between them, and they just float or suspend into the water. And that is why here we are adding alum into the solution. Alum is positively charged. So there is an attraction of forces. There is a neutralization of charges in between the ions. And we are adding polymer polymer, there will be van der Waals forces that acts as a bridge between those attracted ions, and with that it will form into a flux. Formation of flux, when it become denser than water, it will settle down and it cannot be removed from the water, and you cannot withdraw the clear water from the wastewater effluent. Next is chemical flocculation. So in chemical flocculation, you are also adding some chemicals, a polyelectrolyte chemicals into the water. So those polyelectrolytes, so meaning there is a series of electrolytes. When you say electrolytes, those are have e charges. So yeah, that is, it's like it acts like a bridge, and they are commonly positively charged because suspended particles are commonly negatively charged. So that is why it those negatively charged suspended particles attract into the surface of the polyelectrolyte, and it agglomerates, and it then form as a flux. When it's heavy enough, it will settle down on the bottom of the tank. So as shown here, this is actually a actual experiment from the University Lake water. Some suspended particles are present in the lake water, and we are adding flocculant into the lake water. And then rapid mixing, after rapid mixing, so as you can see, after several hours, some of the flocculants, which is positively charged, so yeah, so some of the suspended solids attach into the flocculants. Yeah, and then there's a formation of larger flocks that are ready to settle, and after several hours, as we can see, there is already a separation of the suspended particles down here below and the clear water above. So we can now remove the clear water above without disturbing the clear. We can remove the clear water above without disturbing the water down here below. So yan, by decantation or water valve removal, opening the valve if there is a valve somewhere in the tank, in the actual tank. One of the most important part of the chemical process is disinfection. Disinfection, because we all know that the presence of microorganisms and bacteria in the water should be 0 milligram per liter, because we know that bacteria grows exponentially and they reproduce by binary fission. So that is why we need to kill those pathogenic microorganisms present in the water. And the first process known is ozonation. So that is a strong oxidizing agent, more powerful, 2000 powerful than chlorides, but then it is more expensive, of course, and very difficult to handle, and usually they are used in the industry setup, in the water treatment set up for drinking water. So the common one, so here in the Philippines, we are using chlorine or dechlorination for disinfection. We are adding chlorides and its compound into the water. So there are two mechanisms of disinfection. So when we add chlorine into the wastewater, there is a chlorine demand of water. So those amount of chlorine demand of water is the amount of chlorides that will oxidize the organic matter. The other one, the residual chlorine, that is the amount of chlorine that will disinfect the water, as shown in the following video, we have disinfection processes. And that's all for this topic, chemical treatment of wastewater. Thank you.